Yes, good morning students. Today we are going to take inverse Z transform, and for finding inverse Z transform we are going to take one important theorem, that is convolution theorem. Convolution theorem is one of the most important theorem, and some fixed pattern, fixed steps for finding the inverse in convolution theorem. So, first step is, if we have to find Z inverse of f of z, then convert fz into functions f1z and f2z. It means, firstly what we have to do, inside whatever the function we are having in terms of z, just break it into parts, and when we multiply both the parts we have to get the value of fz again. And after breaking we find z inverse of f1z and denoted as f1, and z inverse of f2z denoted as f2n. And convolution theorem is z inverse f1z into f2z is equal to summation of m is equal to 0 to n f1n f2 n minus n. So basically this is the convolution theorem, and we have to use f1n f2n minus n in this formula, and after expanding we can get the z inverse of given function. Now f1n is getting by z inverse of f1z, f2n is can be get by the z inverse f2z. Instead of n we have to take n, instead of n we have to take n minus m. So simply we are taking one example here. Find z inverse z square upon z minus 1 z minus 2. This is one of the basic example here. So first step what we have to do, we have to find the z inverse of this given function, and according to the steps we have to break fz in two parts. So here fz is z square z minus 1 z minus 2. Now break it in two parts like z minus 1 upon me and z upon z minus 2. Got it everyone? Firstly breaking this in two parts. First one is noted as f1z and second one is f2z. After this we have to find the inverse of both of function. Z inverse f1z is equal to z inverse z upon z minus 1. This is the standard one formula. Here z inverse z upon z minus a. In our earlier lecture we have seen this is the one of the standard formula for a raised to n. So z of n is equal to z upon z minus a. So z inverse z upon z minus a we can write a raised to n, where a is the number mentioned here. So similarly if we are using the formula, what can we get? A is equal to 1. So 1 raised to n, and it is f1n. We can see we have to use the formula in terms of n. So f1n is equal to f1n 1 raised to n, f1n 1 raised to n. Give the number 1. Now the second step, z inverse f2z is equal to z inverse z upon z minus 2. Again the same formula we have to use, z upon z minus 2. In place of a we have to put 2. Then what is the value? 2 raised to n. Now we can see f2 in terms of n minus n. So replace f2 equal to 2 raised to n f2 n minus n, 2 raised to n minus n, and giving the number 2. Is it everyone? Now the next thing, convolution theorem. Z inverse f1z f2z is equal to summation m is equal to 0 to n f1n f2 n minus n. So f1n we can see here, this is 1 raised to n, f2 n minus n is equal to 2 raised to n minus n, n is equal to 0 to n, 1 raised to n, 2 raised to n minus n. Now the next step, what we have to do, first thing, we can see here 2 raised to n minus n. Separate the power and then convert it in positive form. So n is equal to 0 to n, 1 raised to n, 2 raised to n, 2 raised to minus n. Now the next thing, 2 raised to minus n, convert it in positive power. So what can we see? m is equal to 0 to n, 1n, 2n, 1 upon 2 raised to n. 2 raised to n is we have as a constant. Why? Because summation is applying on n. So there is no role of 2 raised to n in this sequence. We are taking it out. Raised to n, summation m is equal to 0 to n, 1 raised to n and 2 raised to n. By combining both the terms, 2 raised to n, m is equal to 0 to n, 1 by 2 raised to n. Now what we have to do? We have to use the geometric expansion series formula. Firstly, we have to expand it from 0 to n, 2 raised to n, 1 by 2 raised to 0, 1 by 2 raised to 1, 1 by 2 raised to 2 up to 1 by 2 raised to n. Here upper value is n. So we are using 1 by 2 raised to n is last term. Now when we see 2 raised to n, 1 plus 1 by 2, 1 by 2 square and so on. By geometric expansion formula, 1 plus r square rn is equal to rn plus 1 minus 1 r minus 1. So when we see compare it, then what about r? 1 by 2. It is 2 raised to n, 1 by 2 raised to n plus 1 minus 1, 1 by 2 raised to 1 by 2 minus 1. After simplifying, what can we get the answer is by taking the LCM in denominator, minus 1 by 2 is that, and here 1 raised to 2 raised to n, 1 n plus 1, 2 raised to n plus 1, 2 raised to n plus 1, 1 minus 2 upon 2. Numerator and denominator term, both we are simplifying separately. So 2 raised to n, 1 raised to n plus 1 is equal to 1, 2 raised to n plus 1, 2 raised to n plus 1, 1 minus 2 is minus 1 and is 2. So 2 raised to n and 2 cancel out by 2 raised to n plus 1 and minus sign 1 minus 2 raised to n plus 1. We are taking the minus sign inside, then our answer is 2 raised to n plus 1 minus 1. So this is convolution theorem, one of the important theorem for finding Z inverse.